Hello guys, welcome to Digital Learners. Today we are going to discuss about that one of the interesting topic in the C language, that is bitwise operators. So what is bitwise operators? So bitwise operators are the one of the type of operators in the C language, but in bitwise operator there is a special purpose uh, is there to introducing the bitwise operators, because these operators can manipulate the bits allocated where the storage allocation, so which directly changes the uh, what it mean, that is storage. So so the operation was done on the bits. So can explain a simple program. So I can write this program. So I at a documentation section, C program for bitwise operator. So we are already know that bitwise operators are totally there are six bitwise operators, that is bitwise and, bitwise or, bitwise XOR, left shift and right shifts, and one's complement. These six are the main bitwise operators in the operators. So first we are know that bitwise and. So bitwise one, whenever when we are seeing the truth table of bitwise operators, so we can say that if both conditions are true, then it is true. So based on this truth table, we can try. First we can draw the program, then we can discuss about these things. And at first I am taking an integer. I am taking an integer a, small a, which its value is 50. I am assigning this 50. So it not requires a heavy program, so it is very simple to understand. So I am asking firstly the values. I am asking values for the initially. So a is 50 and b is equals to 100. So and there is one more thing, that is c. So I have three integers with a, b, c, and I have a values. A is equal to 50 and b is equal to 100. And now c, value of c is equal to, it is an addition of a and b. Sorry, not addition, it is addition a and b. So what is in between this a and b? It is not an addition, so we are going to instead of plus, that is plus symbol, we can take this plus symbol means uh, arithmetic operations. Instead of arithmetic operators, we are using the bitwise operators. So bitwise operators means, and bitwise and or XOR this. So at first we are going to uh, discuss with the bitwise and. So bitwise and is indicated by the and symbol and semicolon. In next line, printf, I want to print the above value. So that is in between quotes, percentage d. So comma, which is assigned from C, which is taken from the C. So this is the simple program. Okay, it is a very short program. To understand it is enough for this concept. So first at bitwise and, so I am also taking remaining of operations also. So then I am taking C is equals to a, bitwise or, and b. So it is not b, it is b. And C is equals to, next, that is percent a. We can skipping the bitwise XOR there, because there is another program we can discuss in another program. So I am going to the left shift B and C is equals to A, right shift B. So first we can discuss these four things and then go to the remaining four. So just copy this print. uh, After each and every value it should print that. So this is a simple program. Now I'm going to save this program with the name of bitwise operators. So bitwise operators, and I'm going to save this. I'm going to compile this. There is no errors and warnings, and run. So it is bitwise. So totally it is confusing. So I'm going to take a new line for each and every one. Slash n percentage d slash n percentage d slash n and one more slash n. So I need a slash n at the first line, so one line gap at the first initial line, and I'm going to save this, compile and run. So you can see this bitwise AND, that is C and A, it is having 32. So because 50 in terms of binary conversions, so it is 0 0 1 0, so something like this. So well, similarly B value 100 also converted into binary system, that is within 8 bits. So that value is converted, that is by using the truth table, when it can, as I said in the previous classes. So when both are in a truth, then it is a final output is also true in the bitwise AND condition. So that's why whenever the true once is there, so then the final bitwise AND operator, that C value also true. Whenever A B having the both bits at the both the power of bits is having the same value, so then C bit at the C bit also having that same value, that is either 1 or 0. So after getting all these things and then converting into the data, that 8 bits into uh, low level language, that is human level language, so then we get that number is 32. Similarly, and bitwise R is can be based on the truth table. It both conditions, if both conditions is false, then it is false. So both conditions is 0, so then it is 0. So that's why the value of there is a maximum number of ones in that uh, bitwise R conditions are obtained. So bitwise R having the high value than compared with the bitwise AND. So one more thing you observe here, whenever if you can add the bitwise and R, so you get these values. So multiplication of integer given values, that is 118 plus 132. So 2 plus 8 is 10, that 10 plus 10 20, 20 plus 30 50, 50 plus 100 150, total 50 plus 100. So this is the bitwise and bitwiser. And once complement is, sorry, left shift and right shift, so it is nothing but just simply shifting one bit into right side and one bit into left side. In the one condition we are shifting that, in the first condition we are shifting this into one bit into right side, and in another condition we are going to shift that into left side. So when one bit is converted into another bit, another side, so then the values will be changes very highly. So this is, we can see this. Okay, this is the bitwise operators, and that is bitwise and bitwise or bitwise XO, left shift and as well as right shift. And there is two more things where, that is ones complement and bitwise XOR. So bitwise XOR also having the same formula. So that is, we can also we can use this here also instead of bitwise, or we are using XOR. So when I am save and compile this, compile and run, then I get bitwise XOR value is 86. So, and finally there is one more thing, that is bitwise ones complement, not bitwise. So it is ones complement. Ones complement is indicated by the negation symbol. So I am going to save and compile this. So there is error, it is not indicated by ones complement. So because it cannot directly taken into the compiler, this compiler is not supporting for this. And one more thing is, the syntax is also mistake. I think there is a small change in syntax, that is that's why I can change this. I cannot turn this at first time thing, so it cannot directly taken. So it can be taken like this. B, A is, there is two condition. A is assigning, A is one's complement to B and B is one's complement to A. There is actually two conditions. So now, and first condition, I am going to take this A is equal to the one's complement of B, and this value is assigned to the C. So I am going to save this and compile and run. So I am going to, I am having this 101 is the my as my value. So if I can, for the second condition, that is B is assigned to A, then I got that 100. So you can see there's just only one bit of is difference in between 100 and 1 bit, but actually it is minus 101, it is 101. There is totally 200 numbers are difference by just changing the one bit. So by adding or subtraction of the just only one bit, so it will vary from, you can see this 100 and 101, minus 101 and plus 100. So this is the concept of bitwise operators. Hope you will be understanding on this concept. And if you can watch that theory session also, so you can better understand, better able to understand. So there's just was that theory conditions. So there is a truth table for the every condition, that is bitwise and or bitwise XOR. So based on the truth table, it can easy to understand this programs. So this is the program for the bitwise operators. Thanks for the watching. Thank you.